Okay, hi everyone.
Hello.
Hello. Okay,
Hello.
how is it going?
I hate compound interest.
Why? It's just a formula.
It's a little much. My calculator keeps saying E when I try to do it.
Oh, like if they write e to the 6, it means you have to multiply by 10 to the power 6.
It'll say like 0.10569 negative E10 something.
Yeah, it means you multiply by 10 to the power 10. Okay, we will see. We will see. We will see in the homework, okay? How is this gonna come up? So before I take the compound one, this is really a formula. It's not really hard once we use the formula. But I start with a small comment about the quiz. There is something still confusing for some students. So the first comment is this. I mean, as a whole, you guys did well. And of course, there are some students who didn't, but I urge them to come to my office hours, but they don't want to. So please do. So the comment is that there is a little bit of confusion with growth rate and growth factor. So if A is A times B to the X, so the B is the growth factor. So just comment about the quiz before I move to, so the growth factor is the B right here. And the relationship between growth factor and growth rate is the following. The growth factor is 1 plus the growth rate. So as just one example, so let us say f of x is, I write 5 times 1.03 to the power x, for example. So this is the growth factor. So growth factor is the B. It means this represents is quantity that every year is 103% of the year before it. And the growth rate here, a lot of you just look at it and then what's the growth rate, but to be very careful, the growth rate, so we go over the relationship. The growth factor is 1 plus the growth rate. It means the growth rate here, the growth rate is the B minus 1, 0.03%. Means that's a quantity that starts up at 5, but growing at the rate of 3% every unit of time. That's how we read that. Now, if the rate is, if B is less than 1, so if let us say f of x is 5, let us say 0.93 to the power x. This is definitely, the B is less than 1. This is really something, an exponential that's decreasing. But what's the growth rate here? So the growth factor, that's the growth factor. It's 1 plus the growth rate. And in this case, the growth rate is the growth factor minus 1. It means it means the growth rate is 0.93 minus 1. It means minus 0.7. Meaning that the growth rate is minus 7%. So this function represents, if you want, it, you can make up any kind of scenario. It can represent, for example, a medication that starts by 5 milligrams, and every hour it decreases by 7%. It decreases by 7% every unit of time. So this is the growth factor, and that's the growth rate. The growth rate tells you how much, by what percent it decreased every unit of time. So that's the mistake that is still occurring in the quiz. Right. Now we go back to the compounding. We're gonna put the formula in front of us and we're gonna do number one. And as I do it, I want all of you basically to tell me, you know, if you are managing with it. So I'm gonna go over number one and we're gonna do it together. First, let us remember the formula. The formula is for the growth, the compounding. So if you deposit an amount P in the bank, so that's the initial deposit, and of an interest of R compounded n times. It means n times a year you get interest on your money. So the formula is 1 plus R over n. I'm gonna get rid of the 0.01, not to avoid any confusion. So R over n to the power nt. So that's the formula. And we're gonna do problem number one, all of it. You know, every word of it, so we know it. So number one is, initially, we're gonna deposit how much? $3,000. So that's the initial amount. So I put initial $3,000. And the interest is 4%. Questions, please ask questions as I move on. If you don't see, let me on. You guys don't be quiet. So at an interest of 4%, A compounded annually. All right. Compounded annually means what? It means once a year you get interest. You put 3,000, they give you 4%. At the end of the year, they give you your money. In between, you cannot cash your money. You don't get any interest within the year. You get your interest at the end of the year. So compounded annually, it means the number of compounding is 1. That's the simplest possible scenario. It means you get your interest once a year at the end of the year. So now we're going to apply the formula verbatim in here. So what is the amount of money after 2 years? My initial is 5,000. 1 plus my R here, I'm going to write it always in decimal. So my R here is 0.04. 0.04 over 1 to the power nt to the power t. So that's the simplest possible scenario. It means 5,000, 1.04 to the power t.
No, it's 3,000, not 5,000.
Oh my goodness. Thank you. All right. So now after 1 year, so that's annually. So after 1 year, it means t equal to 1. The amount of money after 1 year, I'm just gonna plug in 1 for t. And then this is easy to use your calculator to compute it, and I'm gonna use it. It's 3,000 times 1.04. That's it. I'm getting 3,120.
Yeah, I got that.
Yeah. After 5 years, again, I am in the same scenario. It means you're gonna get your interest at the end of the year. If you run out of money, you wanna get your money in the middle of the year, you lose all the interest. Now, after 5 years, it's a simple scenario. Again, that's the easiest possible scenario. To the power 5. And I'm gonna do that, 3,000, 1.04 to the power 5. So I will get 3,649.95 cents.
I have a question.
Yes, I'm listening.
So what happened to the R over N?
What is N in this particular scenario?
1.
Right.
1. So,
Okay, that's what I was getting confused about. Okay.
1. Annually, it means they pay you the interest How many times a year? Once. N is 1. Make sense?
Yeah.
Very good. Now B. We're gonna again try to do B. B. Compounded monthly. What does it mean, compounded monthly? It means how many times a year they pay you interest.
12.
Every month. Every month, it means N equal to 12. Because every month they're going to pay you interest on your money. Of course, they're not going to give you 4% every month. That's impossible. But they give you how much interest they give you every month. So it means that every month they give you that much interest. R over N. That's how much interest they give you every month. What is the R in this case? I'm going to write immediately R in decimal. Otherwise, it's confusing for us. Over 12. That's how much interest they give you every month. So you put your money. After 1 month, they give you that much interest on your money. So if you want to cash your money, you can. And you're going to get interest on it. But that's the interest every month. After 2, so now you accumulated money. After 2 months, they're going to give you interest, not only on the initial, they give you interest also on the interest because you've accumulated a little bit of interest because you already put your money in the bank. On the top of it, you can withdraw your money after 2 months and you don't lose the interest. In the annually, you can withdraw your money only at the end of the year. In the monthly, you can withdraw your money after every month and you don't lose any interest or whatsoever. Now, what's the formula? What is f of t? And I want to apply it verbatim. It's P. P is the initial amount, nothing is changing. Times 1 plus R, which is the 0.04, divided by the number of compounding, 12. To which power? What's the power here?
12.
12 T.
T.
T. It means 12 times T, whatever T is. So that's the formula in this scenario. Now we're gonna find it after 1 year, and we should get more than we got in the annually compounding because we're getting interest on the interest. So let's do that. Sorry. Actually, I'm gonna rewrite what you guys see, but do it with me. So this is my formula. I keep it in front of me and I compute. So at t equal to 1, after 1 year, how much we have? So I have to plug in 1 for t. So I will get 3,000 times 1 plus 0.04 over 12 to the power 12. It's basically 12 times 1 because that's the t, but 12 times 1, it's 12. So this is going to give me the following, 3,000 times. Now again, I'm back to my calculator and I'm going to compute what's between the parentheses. It means 1 plus 0.04 over 12. Did you guys get the same thing as I got?
Yeah.
Now, of course, you're not, in this case, you're not gonna tell me it's 1 because it's not 1. You go at least 2 decimal after the zeros. So to get a decent answer, you're gonna go 1.0033. You don't get 1. You don't only do the first 2 zeros. I want 2 numbers after the zeros. Otherwise, you will have problems. And the reason it's very small because that's the interest per month. So the interest per month is going to be a small number to the power 12. And now let us compute this number. Okay, again, my calculator. 3,000 parentheses 1.0033 close parenthesis to the power 12. And it's 3,120.98 cents. So it's not that much more than before. It's $1 more, not a lot. But what's the benefit of the monthly? It's not the money in this particular case because it's very little money extra. But what's the other benefit?
You don't get a penalty for pulling out your money early.
Exactly. You don't get penalty for pulling out the money. You can pull it after every month. You have no issue with that. Now, after 5 years, and you get the few cents interest, but you can do it. How much money after 5 years? So again, we're going to use the formula verbatim. It's the initial times 1 plus this. So, which is for me 0033. Please, if you don't follow it, sorry, I'm late. I kept trying to, okay. All right. Now, to the power 12t. Remember, 12t, it means 12, you multiply it by t. So what's the power here?
60.
60.
Right, it's 12 times 5. Okay, now I personally prefer to do it this way to avoid any. I first compute the power and then I proceed.
I'm sorry.
Sorry. What?
Where'd you get the 5 from? I'm sorry.
5 years.
5 years. It means the T is 5. They want to tell me how much money you will have after 5 years. The T represents the number of years after you started your investment.
Oh, okay. So A would be 1 year, 5 years.
Right. So the first case,
Gotcha.
T was 1. So I got 12 times 1. Now T is 5. So I got 12 times 5. I want it to be very clear. Please ask me questions if you have any. I mean, of course. Now I go back up to my calculator, I think. So what do I get? 3,000, 1.0033 raised to the power 60. Can you guys see the calculator?
Yeah.
Okay, all of you. I want all of you. So I'm getting 3,655.69 cents or 70 cents. It doesn't really matter. Now let us compare it a little bit with the annual. I mean, if we get less, it means we're doing something wrong. The annual, I got 3,649 and few cents. Now 3,655. So like a $5 extra. Okay? Questions?
In the back of the book, it says a different answer, though.
What did I say there at the back of the book?
For 1 year, it's $3,122.22, and after 5 years, it's $3,662.99.
Okay.
But for me, I just
yes, I can explain the book. I think I can explain the book. All right. The book did not round like this. I imagine. I don't know. So another way to be extremely exact, listen carefully how we can do it to avoid any issues. And usually times. I'm going to redo that without basically computing this number. So I'm going to do it this way. And that's by doing this, I will avoid all kind of rounding. 0.04 divided by 12 to the power 12. And that's the book did.
That's exactly what I got, and I did the same thing.
Right. And the reason I got that answer, I don't know, because I rounded a little bit more than I should. So the book did not round. So if you want exactly, so without rounding, without any rounding, Okay, so I'm gonna redo t equal to 5 without rounding. So we will be on the same page. So I'm gonna do it with no rounding. Okay, I will do
But
that.
if we want to round, we can.
You can, but you know, yeah, you can. But if you become a business person, you don't want to.
Yeah.
Because you lose few dollars as you realize. So f of 5 equal. That's the problem with rounding. That's why I keep telling you take more decimals, because any rounding will affect the problem. So I'm gonna do that again without any rounding to the power 60. And again, I'm gonna do it there. 3,000 times 1 plus 0.04 divided by 12 to the power 60. And now I'm getting 3,662.98. Okay? Now the one daily, I will not round. So we can get exactly the you know, as accurate as possible. All right, so I'm gonna do the last one. So I'm gonna do the daily one. So daily. And we analyze it. Daily, it means my initial amount, so the initial principal, usually the letter P, because it stands for the principal, that's what the P comes from. So the principal is 3,000, and R is 0.04, compounded daily. Compounded daily, it means every day you're getting interest. So it means you're getting interest 365 times a year. It means you can go to the bank and basically withdraw your money almost any day and you don't lose any interest. So what is the formula in this case? It's your initial times 1 plus the R 0.04 over 365 to the power nt. It means 365t, means you multiply by that. Okay, and now I'm going to do the whole problem without any kind of rounding. So after 1 year, how much money you will accumulate? Okay, we'll accumulate 3,000 times 1 plus 0.04 over 365, and this is raised to the power 365. Basically, you multiply it by 1. So, which is the same thing as 3,000 over 365 to the power 365. And now let's see how much we're gonna get without the rounding idea. So it's 3,000 times 1 plus 0.04 divided by 365. This quantity is raised to the power 365. And I'm getting 3,122.42. Are you guys getting anywhere close?
Yeah.
You round up to 43. Is that fine?
Yeah, it doesn't matter. Yeah.
Okay.
Yeah. 1 cent doesn't really matter. Remember, those are cents, so you're fine. All right, t equal to 5. I want you guys to do it without rounding, just to make sure you're plugging in the number correctly. But as I said, my advice to you is first you compute the power, and then you compute the whole term. So what do I mean by that? 1 plus 0.04 over 365, and now what should go here?
365 times 5.
25.
Times 5. So you have, be careful, first compute the power, otherwise you're gonna mess up a little bit. Times the whole thing Now to the power, 365 times 5 is going to give me 1825. Okay, now you guys do it and I do it and see what we get. It's just plugging in. I'm not showing you my calculator now.
You want us to tell you what we got?
Yeah, what you guys got?
Got 3,664 with 16 cents.
Point how much?
1.6.
1.6 or 1.7, it doesn't really matter.
Okay.
Is everybody getting the same answer?
Yeah.
Yeah.
Yep.
Are you having any difficulty using your calculator for that?
No.
Nope.
Anybody? So that's really, I strongly advise you to compute the power and then take. And I want you to do it without rounding because it's not actually, it's not really hard. So rounding is very, very delicate. Rounding is really, really delicate. Okay? Very good. So I will not introduce any new material today. Of course, next Monday we have a lot of new material to be introduced, but I would rather go over review with you for your exam. Did you guys look at the review?
No.
Why not?
I worked a
emailed
lot
you.
of hours last week, and I was gonna do it tomorrow.
Okay, so I'm gonna review a little bit with you, and I urge you to review yourself because I will here to introduce new material today. I want all of you to do well on this exam, and that's it. I want you to do well on the exam. No more, no less. All right. However, I want you to put the review in front of you, and if you guys don't have any specific question to me, I will go over some of the problems that they actually gave you trouble throughout the second part of the course. So the first part is, if my memory is correct, whenever I mentioned domain, you guys had a lot of difficulties with domain. So the first A to E are functions where you have to find the domain. And remember, the domain of the function are all the input value that will yield an output. So when we find the domain, we only put what is acceptable for X. And that's what really the domain is. So I'm gonna, with you, you guys have a piece of paper yourself, and I'm gonna write the functions, and we're gonna work on the domain a little bit. So this is problem number 1 on review. And the question is, find the domain of the following functions. So we start with the first one, f of x equals 4x squared plus 4. And the question is, what's the domain? Which values of x are acceptable and which are not acceptable? So please, I want quick answers so I can do a lot.
All real numbers.
Everything. Is there any value of x that gives me problem? Absolutely not. All real numbers. Okay.
How do you know? How do we know that? See, I was the one who had problems with domain, and I still don't get it.
You know, give me a value of x that you cannot put in here.
It doesn't equal anything, so I don't know where I'm even supposed to start with it. Like when I look at it, I don't know.
Okay, if I give you x equal to 1, can you plug it into this formula?
Yeah, I guess you could plug anything because it doesn't equal anything. It's not an equation.
Yeah, it's a rule. It's a rule. You give it x, it spits out 4x squared plus 4. That's the rule. And the question is, can you put here anything and it still spits out something for you? So if I put 1, does it spits out a number or spits out nonsense? That's my question. A number or nonsense?
A number, I guess.
If you put 10, what this will be spit out? 4 times 10 squared plus 4.
404.
Right. Yeah, I don't care about the answer, but what I care about, does it spit out nonsense or spits out something, number? If I put a million, is there any issue with that? 4 times a million square, no problem. If I put a half, it's gonna square the half. So no matter what you think of a machine, ask yourself, this machine, you give it something, it takes 4 times x squared plus 4. So can I put anything I want here and it will spit out something? Yes, it does. Because no matter what you put, you're squaring it. It's all right. You can square anything. You multiply it by 4. You can do that. And then you add 4. So it's going to be every possible number.
Okay.
Now let's look at the second one, because hopefully by doing more, you can start interacting with it. That's 3 over x minus 1. Again, now I have this machine. You give it something and the machine does the following. It takes 3 over x minus 1. So you give it 2, it takes 3 over 2 minus 1. So the question is, can you give this machine anything and it will spit out? That's really what the domain is. You're right, it's not an equation, it's a rule. But can you give it anything that will spit out something, or it has an issue?
No, the denominator cannot equal 0, so it's all real numbers except for positive 1.
Yeah, 1 will spit out nonsense. Anything else will spit out something. So how can we find the domain? So to find the domain, watch. First, I'm gonna put the parentheses. I need to find when this is 0, because the axes that makes this 0 are the axes that I cannot put in here. This is gonna give me x equal to 1. Every x that makes the denominator 0, give me a problem. So the domain is gonna be f possible x that has the property that it's different from 1. Because the 1 spit out nonsense. So that's the machine. You give it 1, it's gonna blow up. It tells me, you know, I don't understand you. All right? Now let's look at number C.
For B, can I just write it out, all real numbers but positive 1, instead of writing it the way you did, or does it have to be that exact notation?
I did not follow the first thing you said.
So like I wrote out in words, all real numbers but positive 1. You wrote all x.
Oh, that's okay. That's the same thing.
I could do that instead of writing away.
Yeah, it makes sense.
Okay.
Yeah. When something makes sense, it has to make sense. So not all positive numbers, all numbers. They don't have to be positive.
Just real.
Or real numbers, because there is no reason for it. Can I put in -1 in here?
Yes.
Yeah. Can I give me 3 over -1 minus 1 minus 2? No problem. 3 over -2 is -3/2. So all real numbers, but x equal to 1. That will be another way of writing it. Now C. It's the square root of 3x plus 4. Again, my machine, that's the function. It's the rule. You give it the x. My machine will give me 3x plus 4. And the question is, which ones I cannot put in here? Now, whenever you have a square root, of course,
it can't be negative, right?
But what's the it? That's the it we're struggling with.
3 can't be negative.
But 3
Or
is a
like
number.
underneath the square,
What's underneath?
The products. I don't know. What do they call it?
The expression. 3x plus 4.
Greater than 0?
What?
Greater than 0?
Yeah. What we need is, we need this to be greater or equal to 0. That's what we need. Because everything that makes the term under the square root negative will not be acceptable. So we need only the x's that make 3x plus 4 positive. So now we're going to solve for x. I'm solving, I'm not guessing. It means 3x has to be greater than -4. I'm gonna divide by x. It means my x has to be greater than -4/3. So my domain is going to be all x, or real number x, that has the property that this number has to be bigger than -4/3. Okay, when you guys don't see, tell me to lift up the paper. So let's see if this makes sense. So suppose, give me a number bigger than -4/3. I don't know. Is -1 bigger?
Yes.
Okay. It means if I plug in -1 here, I should get something that makes sense. It means if I plug in any number bigger than -4/3, I put it here, the machine will give me something that makes sense. Let's try -1. Well, the machine give me something that makes sense. 3 times -1 is -3 plus 4, that's 1. It's the square root of 1. There is no issue with that. If I give it 3, 3 satisfies this property. 3 times 3, okay, that's 9 plus 4, a positive number. However, if I take a number less than -4/3, this will not be acceptable. So suppose I take x equal -2. -2 does not satisfy this condition because -2 is less than -4/3. If I plug in -2, I'm going to get -6 plus 4, which is going to give me -2. It's not acceptable. So this is giving me all the value that I can put in this box here so that this will give me a real number. Okay, I'm going to A, B, C, D. And f of x equals.
Question, if you divide by a negative inequality, it changes the way it goes, right?
Repeat, because there is some kind of
You end up having to divide it again or multiply it by -1 anyway. That's why you might as well just get rid of the one step. He's talking about if you divide when you're doing an equation, you can do it divide by a negative. But if x is negative, you have to do it again by -1.
But if you can divide by a negative, if you divide by a negative number, you have to change your sense of your inequality.
Yeah.
I'll get back to your question. Okay, so first I want you guys to figure out the domain of this function. It means which values of x. So again, as long as you think of a function as a rule. And my question is, which you cannot put here, or which numbers you can put in this box that will give you something that makes sense. I'll give you a minute to think through that, and then I'm going to ask you questions. So you have the time, what can I put here? Can I put anything? There are things I can't put.
You can't put 0.
I cannot put 0. Absolutely. Because give me 1/0. Is it the only number I cannot put?
That's it.
Let's think through that a little bit more. I have a denominator.
Would you equal that to 0 and then?
Exactly. First, I'm going to ask myself, which values will make this 0?
-1.
-1. And so let us, because we don't want to guess, sometimes it's hard to guess, I'm going to set this equal to 0 and ask myself, what make this equal to 0? Now, how do we solve? As I said several times, that's a quadratic. We either use a quadratic formula, which is really, too much in this problem, or factor. And obviously, I can factor the x in this problem. So it means that x equal to 0 or x equal to -1. So what makes this 0 is 0 and -1 will make this 0. So what's going to be the domain now? which values I can't put here. I can't put here 0 because this gives me 1 over 0, nonsense. Also, I cannot put -1 because -1 will give me 1 over the quantity -1 squared, which is 1, -1, 1 over 0. So the domain is going to be all real numbers where x is not such that x is different from 0 and x different from -1. So those are the domain. Anything except 0 and -1. Anything else will be all right. Okay. Now I will look at the last one and I will move to something different. So this was one over. This is give you a lot of problems always. That's why I'm going through that. Okay, now I give you a few minutes to do it. Not few minutes, 2 minutes to do that. Again, that's the function. You have to think of the rule. This is a rule. It takes input to 1 over the square root of 6 times the input plus 2. And my question, can I put anything here or some stuff will spit out nonsense? All right, what did you guys get?
Would it be 6x plus 2 is greater than or equal to 2?
That's what we need. We need every x that make this positive. But here, can we put the equality sign or not? It should be strictly positive. We cannot have 0 because 0 will make the denominator 0. Now it's a simple inequality to solve. How to solve it? We need to isolate the x. And then I'm dividing by +6. It means x bigger than -1/3. So the only values of x I'm going to be allowing here everything greater than -1/3. So the domain will be all values of x such that x strictly greater than -1/3. So will -1 be allowed?
No.
Will -1
No.
be allowed?
No.
Because
Because
That'll
-1
make-
is less than 1/3.
-1/3.
exactly. And another reason, if you plug it here, what are you getting?
-6 plus 2.
Exactly, we're getting the square root of -4, which is not a real number. So 2 reasons why we cannot put -1 here. However, can I put 0?
Yeah.
Well, 0, yeah, because it's bigger than -1/3. Also, if you put 0 for x, you're gonna get square root of 2, which is an honest to goodness real number. This is what we mean by the domain. Okay, so review those problems. And before I move on, there is a comment I want to make because I think one of your classmates asked me the following question if I understand. Suppose you're trying to solve this equation, -2x plus 4, whatever, positive, okay? And the student did, this is gonna give actually, the student wanted to isolate the x by bringing the 4 to the other side. So far, algebraically correct. Now, if you want to isolate the x, you have to divide by -2. So you want to divide by -2. This by -2 and this by -2. But what will happen if you have an inequality and you divide by -2, you have to reverse the inequality. And it's going to give you x has to be -4 over -2, x to be less than 2. So if you have an inequality and you divide by a negative number, you have to reverse it. And that's the only remark, that's the only thing that you have to watch for. Because 2 is less than 4. But if you multiply both terms by a -1, which is a negative number, what will happen? -2 is going to be larger than -4. So inequality, if you multiply or divide by a negative number, you have to reverse the sense of the inequality. Any other questions about that piece? Okay. Now the other part of the test is going to cover the piecewise defined function. And piecewise defined, it means you have a function which is not given by one rule. And it's given by different rule, and the rule really depends on where your input is. So unlike those where there is one rule that governs the function, piecewise is different rule, and the rule depends on where your input is, where your x value is. So I will do, my idea is to do 2 problems along those lines. So to remind you of this question, and then it's up to you to review. So I'm going to define the following function. It's 2x plus 1 so that's the rule. If my x have this property, and it's minus x plus 6 if my x have this property. So that's a piecewise. So it's different rule depending on where your x value is. So I'm going to evaluate each of the following. That's my first question. So I'm going to pick some values, evaluate them. Not everything I have, but some of them. That's my memory, you guys. That's fine at this stage. And so what is f of -1? Quickly. So -1, that's the x value. -1, is it in here or in here? X -1 is less than 1, so that's the rule that applies. So the rule is, which is -2 plus 1, which is -1. So if you guys remember this stuff, please let me know. So what is f of 3? Which rule we use? This or that?
The bottom one.
The bottom one, because 3, this is the x value. Which property does it satisfy? This property or that property? 3 definitely verify this property because it's 1 and 4. So the rule, it tells me that you take it, which is equal to 3. So that's how we work with those ones. That's how we read them. Now part B was sketch the graph. How are we going to sketch the graph of this? So let us remember how we sketch the graph. This function is going to be 2 pieces. Up to 1, there is one rule. So we have one graph. You guys tell me, lift up the paper or something. And between 1 and 4, I have a totally different graph. So I'm going to rewrite the function in front of us so we can see the whole. So it's 2x plus 1 and minus x plus 6 for x between 1 and 4. All right. So how are we going to sketch it? We're going to do 2 pieces. I'm going to sketch it up to 1, and I'm going to sketch from 1 to 4. Up to 1, the output is 2x plus 1. Now, we should know that 2x plus 1 is the equation of a line. So to sketch 2x plus 1, I just have to sketch the line. X, 2x plus 1. Now, how can I sketch a line? I need 2 points. And then if I have 2 points, I can draw my line.
You put
So,
zeros, 1.
I put zeros, of course. I have to put values less than 1. It's crucial. So I'm not going to put 0 and 2. This would be absolutely not smart.
0
And 1. You can put -1. Yeah, I like 1 because I want to know what's happening right there. Where should I stop the graph? At 0, this is a 1. At 1 is 2 times 1. That's a 3, right? So I'm going to graph up to 1 and I stop. So at 0, I am at 1. And that's included. And 1, I am at 3. Is the 3 included in the graph? is this point basically closed or open, if you remember? At 1,
Closed point.
that's going to be closed because we have equality. And this would be my first piece of the problem. I stop at 1. So this piece represents the 2x plus 1 piece. Now the minus x plus 6, I'm going to draw it here. Again, we know it's a line, so that's x and minus x plus 6.
I have a question. Why does a line keep going to the left and not stop? Why does a line keep going down?
Because I'm not stopping from the left here. So can your x value take the value minus 2?
Yes.
Can it take minus 3?
Yes.
Minus 4?
Yes.
Do you see the point?
Everything less or equal.
Less than minus 1. So it has to go all the way. We're not stopping it any place. I did not put between, like whatever, minus 2 and 1. I don't have that. It's all the way till 1. So it keeps going down all the way up. Did I answer the question?
Yes.
I hope. I don't know. Okay. Now that's different. Now between 1 and 4. So now I'm actually restricted. I'm not telling you for x bigger than 1. I'm telling you for x between 1 and 4. So how it's going to be? Again, it's a line. And how is this line? How can I graph it? We can take 2 points. Okay, which point do you want me to take?
You could do 1 and 4.
I'm going to do 1 and 4, but we're going to be very smart about them, those. At 1, I will have minus 1 plus 6, which is 5, and minus 4 plus 6, which is 2. Am I right? Yeah. So now let us sketch them. At 1, it's 5. But is this 5 included? Yes or no? So at 1, this is 1. The line would have had this point, but it doesn't because that's strictly bigger than 1. So that's my open circle right there. But you have to be very careful. It's on the top of 1. It's right there. At 4, my function takes the value 2. So this is 1, 2. This is 2. So it is 2 right here. But it's, sorry, my apology. That's 4. So that's 2. That's 4, 2. And this will be my line. So my graph will consist of those 2 pieces. This is the piece minus x plus 6, and this is the piece 2x plus 1. And it's open here because 1 is not included, and it's open here because 4 is not included. And here we should be very careful how we sketch it. Please ask a question.
No, we good.
Okay. Now, let us say a student does this for me. How would I know immediately that's nonsense?
They do what?
If a student does something like that.
Use an open point.
Because there's, I don't know. I don't know how to say that.
1 and 4, so
Oh, because there's 2 values for.
Right, exactly. This is
yeah.
not the graph of a function, because the student telling me that for 1/2 there are 2 outputs. This will not be a graph of a function, and that would be nonsense. So you cannot have 2 outputs for the same input. So you have to be very careful when we're drawing those. Okay, the last question was find the domain. In this case, the domain is everything less than 4. Everything less than 4 is in the domain. After 4, I did not give you any rule, so you cannot tell me what's the domain. What's the range? The range are all the output value. It means all the value on the y-axis that are obtained. And the output value here is going to be everything less than 5. Will be an output. So the range is going to be all the y's which are strictly less than 5. 6 is, yes, I'm listening.
What about the other way? It'll be like negative infinity.
Yes, negative infinity, sorry, comma, 5, open, this way. That's interval notation. or you can write all values of y such that y is strictly less than 5. I will accept either one.
So the domain was what again? All x was.
The domain, so that's the range.
The domain is everything less than 4.
Right. The domain, everything less than 4. All values of x such that x is less than 4. Why this is domain? If I ask you f of 5, can you give me an output? I gave you no rule for something bigger than 5, bigger than 4. So you cannot give me an output. And that's really how my function is.
And for the domain, we could use the interval notation too.
You can use, and this one, that's an easy interval notation. This is from -infinity 4 open at 4.
Okay.
Okay. All right, let us proceed. I would like to look at one of those. So I'm trying to review the stuff that we've done before the spring break and before all this madness we're going through. And the other part, I mean, I've done it a lot, so you guys have to review it because it's really highly representative. So the second problem I'm going to do is, which is problem number 5 on the review, which says I give you the graph and you will have to give me the rule. Okay, so this is the graph and you have to give me the functions that reflect this graph. Okay, how do we do those type of problems?
You have to, don't you have to find your points? I would write my points down first.
Yes, and what else? Keep talking. I'm going to look at this as a line, L1.
Wouldn't it be like linear?
Yeah.
Right, that's linear. I'm going to look at this as another line.
So if you
I'm
have
going to find the equation of the line, the first one, L1, and the equation of the second, and then put them together. Is that clear?
yes.
Let's start with L1. It's linear. So to find the equation of L1, I need 2 points. So 2 points, X, Y. Okay, the points you can give me, you just stare at it and you take 2 easy points. Like here, one easy point is going to be, and if you guys probably don't see it very well unless you have the worksheet in front of you. One easy point is -1. This point here, I'm after this point. -1, -2. You guys see which point I picked?
Yes.
Yeah, the other point, you can pick 2, 1, or you can pick, for example, 2 zeros. So pick the one that you like. So that's or much easier than that. You can pick the intercept itself. It means you can pick this point here, because the intercept is nice if we can find it. So this point would be 0 and -1. Now it's a line. That's linear. We know what to do with linear. You compute the slope, which is going to be -1 plus 2 over 1, which is going to give me a 1. And actually, we expect that. We go by 1. And the equation, you can use point slope, or you can put the slope intercept. Y equal mx plus b, m equal to 1. It means y is x plus b. Now to find b, you say you use this point. So -1 is 0 plus b, b equal -1. And we know that because that's the intercept. So my y would be equal plus x minus 1. This will give me my line L1. Now you do the same for L2. Verbatim, the same. And how will my function look like? My function would be the following. It's x minus 1. It means L1 for the first piece. It means this is the rule as long as my x is between -1 and 2. That would be the rule. If x is between 2 and 5, how can we find this one?
Same way.
What?
Same way, 2 points and point slope
Right.
formula.
To do that, we need to find the equation of L2, which is a line, because it's not hard to find it. Pick 2 points, find the equation, and that's the end of that. And that's what give me the formula.
Wait, I got lost. How did you get x minus 1?
Okay, you got the point. You have the point.
Yeah, I
right?
got all that. I got b equal -1. I got to there, but then I don't know what happened.
Yeah, plug it in. What's the m? What's the slope?
1.
Yeah, mx.
Okay,
And
so all
it's
you have to do is all that, and then that gives you.
Right. Or that's one way, or you can use the point slope for and review the point slope for.
I don't like point slope.
Okay, is this understood though? And for L2, you do the same thing. And we've been working with linear function a lot lately, so this should not be anything new to you. All right, so that takes care of, make sure you go over problem number 6 because we're getting close to, okay, number 6. Now, the other question you're gonna be asked is composition because we have to remember the composition. So I will look at number, whatever. Number 7, and I will do only one question or 2 questions at most to remind you composition. So now you have a solution for those on Blackboard, and my g of x equal to x plus 3. So let us remember the definition of decomposition. So what is f composed with g of x? So what does this notation mean? And then we apply. It means the following. You start with x, you compute g of x, and after you do that, you compute f of g of x. So I'm going to do 2 problems just to remind you of the composition. So let us compute f composed with g of whatever, 2. It means that you start, input 2, you compute g of 2. Then you use g of 2 as the input for f, and you compute f of g of 2. So now, first, I'm going to find g of 2. What's g of 2? 2 times 2 plus 3, 4 plus 3 is equal to 7. So what does f do? It takes 1 over. So this is going to become f of 7. So it's going to be 7 minus 2, which is 1 over 4. Okay? Now I'm going to do another one, which is without a fixed number. G composed with f of x. First, what is the definition? So this is g of f of x. G of f of x. But what is f of x? What does f do? It's 1 over.
We can't see.
Yeah, thanks, Doran. I want everybody to do that. Tell me I don't see. Because sometimes I'm writing. I'm not looking every minute at the screen. I try to, but sometimes I forget. But this is f of x. So that's g of x minus 2. Very good. But what does g do? G does the following. It's 2 times what you give it plus 3. So this is going to be equal to 2 times 1 over x minus 2 plus 3. So that's the setup. Now let us say I ask you, I want you to write this as one fraction. So I want to make sure that you guys can find common denominator. So how are we going to do that? First, 2 times this, by now we should know when you multiply fraction, we multiply across. 2 times 1, it's 2. And this is x minus 2. Because this is, I think of it as 2 over 1. plus 3. Now, common denominator, which is x minus 2, and it's going to give me 2 over x minus 2 plus 3 times x minus 2 over x minus 2. So I'm finding a common denominator. The reason for common denominator is we can combine the numerator. So now I can combine those, and I get 2 plus 3 times x minus 2. Now I'm going to distribute. I will get 2 plus 3x minus 6 over x minus 2. And finally, so at this stage, I'm doing algebra, and that's going to give me this quantity down there. Okay, so that's the idea of composition of two functions. Now, the other idea we have, now another problem I gave you is basically graphically. So, and the idea of a graph is should not really scare us. Once you use the definition, graphically you are actually all right. That's really how graphing is. So if you compute g of f of 1, use definition. This is g of f of 1. You use the graph to compute f of 1. So my graph is telling me that that's 5, that's 1. According to the graph here, f of 1 is minus 4. So that's g of minus 4. And then I go back to the graph. What does g do to minus 4? G of minus 4 is equal to 0. So you basically follow the graph. Now the inverse. What is the inverse? Do you remember what's the inverse? The inverse is the following idea. If f is a function that take basically 1 to 2, f inverse is the function we take 2 back to 1. So f inverse is the function that take the output of f back to that input. So if f takes x to y, f inverse is a new function that's going to take y back to x. And the question is how to find those values. Okay. So this is the graph of a function. I'm going to do the first two problems, A and B, to remind you the f inverse. F of 0, it means what's the output at 0. If this is 0, that's the output at 0. According to my picture, that seems to be 2.5. What is f inverse of 0? So what does it mean to find f inverse of 0? It means we need to find the output such that f of t equal to 0. So I repeat, finding f inverse of 0 is the box such that f of the box is equal to 0. That's what f inverse. What's the input that f takes to 0? So graphically, what's f inverse of 0? Which input does f takes to 0?
Oh, 2.
2. F inverse is equal to 2. I will do one more because before going through the formula. What is f inverse of 1?
Isn't that negative 2?
What? Negative 2. Thank you very much.
Negative 2.
Yeah, thanks, Roxanne. What's f inverse of 1? It means I'm looking for the input that f takes to 1. Now it means 1 is the input. Sorry, 1 is here. And I'm asking you which input f takes to 1. This is going to put me right there. That's the f inverse. And according to what I have, if I'm reading this correctly, this is minus 1.5. Okay? So that's graphically. Now, formula-wise, I'm going to pick two problems, and we're going to do the formulas. So how do we do it formula-wise? So graphically, basically, to find f inverse of 1, 1 is the output of f. You're after the input where the output is 1. Now, how we can do it? Basically, algebraic. So how to find a formula? I'm gonna pick two of those and I'm gonna do them almost out of time. So I'll do the easy one first and I'll do a harder one second. So suppose I have the function f of x equal 4x plus 5. Find a formula for f inverse of t. What does it mean to find a formula? It means the following. We need to find f inverse of t. Means we want to find x, we want to find the input such that f of x equal to t. We're going to find the x let's set f of x equal to t. So we're going to set 4x plus 5 equal to t and solve for x in terms of t. So now I'm going to assume that I know t and I'm going to find the input in terms of t. So I'm going to isolate x. So you help me quickly in the isolation process.
It's
T minus 5 over 4.
minus 5.
Minus 5.
T minus 5.
And then
Over
quickly
4.
divide by
4.
It means the inverse function is given by the rule t minus 5 over 4. So if I know the output, this formula will give me the input that goes to that output. Okay, I will do definitely one more. Let's do that d, for example. And here f of x equal 3 square root of x. And the question is find a formula. So we're going to set f of x equal to t and solve for t in terms of x. All right, means equal to t. And I want to solve for x. All right, back to you. You are faced with this problem. How do you do it?
Divide both sides by 3.
Immediately, I want a way to isolate my x. So I want to divide both terms by 3. And then quickly, how can I get rid of the square root?
Square both sides.
Square both sides. X t over 3 squared, it means t over 3 times t over 3 is going to give me t squared over 9. So it means my inverse function is t squared over 9. You give me an output, I give you the input that goes to this output. Okay, so that's the idea of the F inverse. And I mean, you guys work with the other problems. So this is the piece that we did before, basically before the spring break. The other part of the course is the quadratic function. And the main thing, what I want from the quadratic are the following. First, we have to know that, actually on Blackboard, I have a summary for everything I want you to know about quadratic. First, therefore, it's ax squared plus bx plus c. That's the 4, where a is non-zero. Sorry, capital B, capital C. That's to be consistent. Where a is non-zero. And the graph depends on a, positive versus negative. Now, the two things that are important about the quadratic are the vertex and the zeros. Those what we care about. And the x-coordinate of the vertex, we have a formula for them. And if a is positive, the x-coordinate will give me the smallest value obtained by the function. If a is negative, the x-coordinate gives me the largest value obtained by the function. The y-coordinate, I can plug in the x-coordinate into this expression. Now, the zeros, it means we need to solve them. That's the zeros. And here we solve. So the question is, can I factor? You can factor, you factor. Always start with that. You can't factor is where we start using our quadratic formula, but used correctly. Okay, so please review the quiz. That's really pertinent to this problem. Before I move on, when I gave you a problem along those lines, there is one question that some of you did not really answer correctly, which surprised me, was the following. I forgot what was the problem I gave you on the quiz, so I'm going to make up my own problem. Suppose I give you x squared plus 2x plus 2. Okay? And so we can graph this function. And my question was, solve f of x equal to 12. All right, some student. Okay, what am I asking for here?
Set the equation equal to 12.
Right, set the equation equal to 12. So let us say this is the graph. Solve f of x, it means 12 is an output. And I'm asking you to find the input that goes to 12. Some student plugged in 12 here. That's not right. If I ask you what is f of 12, you plug in 12. But if I'm asking you, solve f of x equal to 12, it means the output is 12, and you're gonna find the x that makes the output 12. It means you're gonna set this equal to 12 and solve. Now, how do you do that? You subtract 12 equal to 0, and then you solve, whether using the quadratic or splitting into pieces. Okay, so that was a mistake that surprised me when I gave this problem, because we've done a lot like that. Now, the last part of your exam would be basically about exponential. I mean, everything we've seen about the exponential. So I'll take a few more minutes, but then my first time is up. So this question, for example, I gave you a bunch of graphs, and I tell you which formula match which graph. Can you guys see anything?
Mm-hmm.
Okay, so I have the first one. I rewrite them so it will be clearer. It's 2.9 to the x. The second is 2.5, 2.8. So I have always the same initial value, but I'm changing is the growth factor. F of x and f of x. And I'm asking you to match. So I call this I, 2i, 3i, and 4i. And I ask you to match. So, I don't know. Tell me.
C and D are going to be 1 and 4, right?
So C and D decreasing. Now we know the graph of the exponential. The B, like here, B is 0.9. B is 0.7. B is 1.8. B is 1.5. Agree with me?
Yeah.
Yeah. Now, the exponential is increasing if B is bigger than 1. Because two reasons. If B bigger than 1, it means every time you are multiplying. If you think of an exponential function where when x increases by 1, the y value is multiplied by B. So if you multiply a number by a number bigger than 1, the number gets larger.
Mm-hmm.
So I, 2i, and 3i, those will be increasing because I'm going to multiply by a number larger than 1. I and 4, 1 and 4 will be decreasing. So this will help me to rule out two things. So those correspond to A and B. Now, which one is A and which one is B? Which one is growing faster than the other one?
B is growing more than A.
Which
A is growing faster.
A is, this one's growing faster. How do you guys tell?
Faster or more? What's the difference?
It's the same thing. I will
Because
not argue that.
A is
Steeper.
increasing closer to 0 than B is.
It's steeper also. Watch, if I pick any value here,
Oh, okay.
which one is larger? This one or that one? Which point? Is the point on the graph of B or the point on the graph of A larger?
On A.
On A, it means A, assume those are population growth. And this is after 1 year. Which population is growing faster after 1 year? Population A or population B, graphically?
A.
A. So A is growing faster. Is that very clear? Now, if you go back to those, which one growing faster? 2 or 3? Absolutely 3. In terms of rate, this is growing at the rate of 8%. This is growing at the rate of 5%. So this one is growing faster. So after 1 year, since they have the same initial value, 3 will be definitely larger because you're multiplying by 1.8. Here you're multiplying by 1.5. So 2, 3 is the one. So the larger the B, the steeper is the function. So B is gonna be the 2i, and A will be the 3i.
Okay.
What about C and D? Think along the same line. Which one is dipping faster than the other?
D is going faster.
Yeah, because this one is going 10% per year. It's going down by 30% per year. This is decreasing way, way, way faster. So this is gonna be the 4i, and this is gonna be the I. So the smaller the B, if B is less than 1, the smaller the B, the more the function decreases. That's the picture. And then the rest, we've been doing a lot of it. I look at 13 and then I let you guys go. In number 13, I like this problem. It's simple, but the reason I like it is that I want you to tell me each time whether it's a linear or an exponential. And that's really what I care about this. I've assigned this before, actually, as a homework problem. So we have a population, it starts at 5,000. And it decreases by 100 people per year. Every year it decreases by 100 people. Is this a linear or an exponential growth?
Linear.
Linear.
That's a linear. And the formula for the population is easy because it starts at 5,000 and it decreases by 100 every unit of time. That's the slope. B, it decreases by 8% per year. Is that a linear or an exponential growth?
Exponential.
That's exponential, by the same percent exponential. And it decreases, so it starts by 5,000. The rate is minus 0.08, so it means 0.92. And the rest is the same. Increase 0.3, that's an exponential. Increase by 50, that's a linear. So linear by the same amount, exponential by the same percent or by the same factor. All right, so I guess I am done. Please finish the worksheet. Of course, the exam will not have, you know, it will not everything. Of course, this will take lots of time, but it will be quite representative. Review all the problems about exponential, the one we did in class, the one I'm assigning here. And if you have any questions and you want to join me or meet me in a meeting, please just email me and I can set up a meeting with you before Wednesday. Now, of course, on Wednesday we have office hours. But if you guys, want to have a question, something's not clear, you just send me an email And I will try to set up some times where I can meet with you. Is that very clear? Don't wait for the last minute.
Yeah.
I was gonna ask if we could have like maybe like a meeting the day before, like on Tuesday, like tomorrow, as a class again, like we usually do, or no?
I can arrange a meeting if you guys want, but you have to come up with questions. Okay? So
Well, then think about it and then put up an announcement what time
Right.
you're free, and then if we can do it, then send that
since you
meeting.
guys are working, I'm gonna make one suggestion, and I wanna see what you guys have to say, because I know a lot of you are working. I'm working, but I'm working from home, so I'm more flexible in a way. So in the morning after question, because I have all my classes in the morning tomorrow. So I will make suggestions, and I want to see if it agree with you. Will this be a good time?
Yeah, that would work.
Yeah.
Yeah, I don't have a problem with that.
Okay, everybody, I want almost all of you to agree. Will this be a good time for all of you? Because I want to arrange the meeting, and I will put the URL on Blackboard. But is this a good time?
Yes.
Anybody
Yeah,
has?
that's fine.
Okay, so please come with questions, so to make it really very useful. Otherwise, it will be a waste of our time. But I'm willing to meet with you tomorrow between 5 and 6:15, and I answer any questions you have, and I will set up. Now for the exam. Now we have office hours from 4 to 5. I will open the test at 5:50. No, sorry. No, I'm right. No, I'm sorry. I'm right. I'm wrong. So I will open it at 4:50. Okay. By 5, do you guys have printers at home?
No.
No? Okay.
You said
Right.
printers?
Yeah, it's not important. I'm asking you, do you have a printer?
I do.
Okay. If you have the printer, by 5, it should be printed. If you don't have a printer, you just open the, by 5, I want the test to be in front of you. That's what I want. Okay, and you have to start. Now I want your video to be on. So I want to see you guys. I missed you. So I will be there. I will be present. Meaning, if you have questions, you can ask me a question, but it has to be in private. And you have to ask me through chat. Is that clear? So I will be present. I will be physically in front of my computer. And I will close at, so you guys start at 5. I will close at 6:45. Meaning that you guys have to start uploading. I don't know how long it takes you to upload, because I really want it to be on Blackboard, because it's a nightmare for me as an email. So I would like it to be uploaded. So if I close at 6:45, I'm assuming you should be done by 6:30. And this will give you 15 minutes to upload. Is that very clear?
Yes.
Yes.
Okay, so 5 sharp, you will be starting. I want the video on. I will be there. I will close the exam at 6:45. And so you start uploading at 6:30. I don't know how long it takes you to upload. And that's it. So tomorrow I'm going to arrange a meeting right now between 5 and 6:15. Please work on the problems by yourself and come with questions. So we will make it a very useful hour. All right?
Okay.
Okay. Bye-bye, guys. And the best of
Later.
luck. See you soon. Bye.